Hello students. So welcome to this session in which we are going to discuss the paper of JEE Main 2025. This is 22nd January Shift 2 paper. As you can see on the screen, we had produced a very nice result this time and we have got a full score 300 out of 300. So I wish you also best of luck for the next shift that is going to happen in April. So please look at all the solutions carefully. That will be a real good help for you guys for the next JEE Main, upcoming JEE Main. So without wasting any time, let's start. So here I am presenting question by question and I will solve them one by one. So this is the first question. This may not be the first question in your set. So whatever order we have written, you please follow that. So I'll start with the question. We have a diatomic gas. So for rigid molecules, we are given gamma 1 and then we are given gamma 2 for another diatomic gas which also has vibrational mode. Now if it is rigid, that means there are no vibrations and the degree of freedom would be 5, 3 translation and 2 rotation. Whereas in case we also take into account vibration, then the degrees of freedom will become 7. It will be 3 translation, 2 rotation and 1 vibrational mode contributing 2 degrees of freedom. So CV is FR by 2 and CP is CV plus R. So I can find out CV for first case. In the first case, we'll take F as 5, so I get CV as 5R by 2, CP will be 7R by 2, gamma 1 will be 7 by 5. In the second case, I'll get CV as 7R by 2, CP will be plus 2, so 9R by 2, so I'll get gamma 2 as 9 by 7. So 7 by 5 is 1.4, 9 by 7 is approximately 1.2 something, right? So approximately 1.3, let's say. Now let's look at the option. So we have the option in which gamma 1 is more than gamma 2. So option 1 is the correct answer. So correct answer is 1. All right, next question. So here we have an electron which is projected perpendicular to uniform magnetic field B and therefore it moves in a circle. Now this is a nice question in which we have mixed the Bohr's quantization along with this and we are calculating the radius. Now keyword to notice, radius in the first excited state. So first excited state, that means principal quantum number has been taken as 2. Be careful about that. So n you will take as 2. Now for the motion of a charged particle in magnetic field, we have R is equal to mv by qb. By Bohr's quantization principle, I have mvr is equal to n times of h by 2 pi. Now we want to express radius in terms of other parameters. I need to eliminate velocity from these two expressions. So best idea is multiply this equation with r. So you get r square is equal to mvr by qb and mvr can be replaced by nh by 2 pi. Now if I put n as 2, then I get r as h by pi qb and therefore r is square root of h by pi qb. So I get the answer h by pi eb. So option 2 is the answer. So this is a nice question. We have mixed the idea of motion of a charged particle in magnetic field with the Bohr's quantization principle. Whenever it is written Bohr's quantization principle, you must come to this mvr is equal to nh by 2 pi. Alright, let's go to the next question. So this is an assertion reason based question. So basically we are given two statements. A simple pendulum is taken to a planet of mass and radius 4 times and 2 times respectively than the earth. The time period remains same on earth and the planet. We'll verify whether this is true or not. First let's read the reason also. The mass of the pendulum remains unchanged at earth and at the other planet, and we want to find out which one is true and which one is false and whether it is a correct explanation or not. Now I would here like to first focus on reason. Reason says that the mass remains unchanged. So reason is for sure true. And for assertion, I will verify whether it is correct or not. But before that, I will tell you we can find the answer without that. Time period is 2 pi square root of L by G. So time period does not depend on the mass. So reason cannot explain the assertion. That is for sure. Now only thing that is need to be verified is whether the assertion is true or false. So the same pendulum has been shifted from Earth to the other planet. So it is about acceleration due to gravity. The gravity value is given by g times mass of the planet divided by square of the radius of the planet. Now the mass has become 4 times and radius has become 2 times. So radius squared will become 4 times and therefore g remains same. And if g remains same, then the time period will remain the same. So assertion is true, reason is also true, but it is not the correct explanation. So answer is 1. So correct answer is 1. Okay, so I hope you are able to understand. Let's move on to the next question. So this question is about a rigid spherical ball which is dropped in a vertical tube containing glycerin, and the velocity becomes constant after some time. So basically it would have required a terminal velocity, and the forces must have been balanced. The force of gravity, the viscous force and the buoyant force, they would be balancing each other. Now he is saying that density of glycerin is half the density of the ball. The density of the glycerin is half the density of the ball, and we want to find out the viscous force acting on the ball. So at the final stage we are talking about. So in the final stage, when it has acquired a terminal velocity, the net force on it must have become 0. One of the force would be mg. We are already given that the mass is m, and the density of the glycerin is half. So density of glycerin is half. So for same volume, glycerin will weigh half. So it must be exerting a buoyant force of mg by 2. You need to understand, buoyant force is V rho g. Since this density is half of that of the object, therefore the mass must be, weight must be half. So mg by 2, and since velocity is constant, there must be a viscous force, and clearly the viscous force must be equal to mg by 2. So answer is option 1. Alright, let's go on to the next question. So we have been given certain thermodynamic variables, and it is asking which of the variable is intensive or extensive. So first understand what is the meaning of intensive and extensive. When I say something is extensive, it will depend on the total amount. For example, let's say mass, let's say volume. Volume is an extensive variable. But if I talk about a density, density is going to be an intensive variable. Now knowing the definition, you can easily check which one is intensive, which one is extensive. Let's talk about internal energy. So internal energy, what do you think? It must be extensive. If I take more substance, it will be more. Volume, it will be extensive. Okay, let me write with yellow, it is brighter. And if we talk about temperature, so temperature of 1 kg or temperature of half kg, it should be same. So temperature is intensive. Density, it should be intensive. So let's verify now. So first says internal energy, volume and mass are extensive. Let's verify this carefully. Internal energy is extensive, volume is extensive, mass is extensive. This is correct. Pressure is intensive, temperature is intensive, density is intensive. This is also correct. Volume is not intensive. This is wrong. Temperature is not extensive. This is wrong. So A and B are correct. So option 3 is the correct answer. Okay, this is a nice question on the dimensional formula for capacitance. So you will always find questions like this in which you will be required to calculate the dimensional formula. The best way is think of a very nice formula in which you are able to think of all other quantities. and read the question carefully. It is interested in terms of M, L, T and C in terms of charge. So that actually makes our life easier, because if I want to think of capacitance, I will go for energy. Energy is Q squared by 2C. So energy stored is Q squared by 2C. So capacitance will be Q square by 2U. So the dimensional formula for capacitance will be charge squared divided by energy. So I should get the answer C square upon energy. So I remember it is mL2 T minus 2. If you are not able to remember, you can remember half mv square and find it. So C square m minus 1 L2 T plus 2. Let me look at the option. So option 2 is correct. So the answer is option 2. All right, let's go further. Now this is another interesting question. So this time JEE Main have actually improved a lot, and they have really given nice questions. They are not direct one step question, they are giving multiple steps question. This is a very interesting question. So we are given a short dipole. So for a short dipole which is placed at origin, so we are having a short dipole placed at origin. Dipole moment is along x-axis as shown in the figure. Potential at A is somewhere on axial line. So A is axial line. The potential on the axial line is V naught and E naught, and we want to find it at B, which is equatorial line. Now one of the interesting thing is, at the equatorial line you are equidistant from the charges, and therefore the potential has to be 0. So potential is 0. So either 2 or 4 should come. Now let's talk about electric field. This is a very nice question. They have set a good trap also. They have given this distance r, this distance 2r. You need to remember that on the axial line field is 2kp by r cube, whereas on the equatorial line field is kp by r cube. So there will be a half factor coming when we move from axial to equatorial. So 1 by 2 because of this 2 missing in the formula, and then the distance has doubled, and if r is doubled, its cube 1 by 8 factor should also come. So 1 by 16. So that means we will get the answer as option 2 is the answer. Potential is 0 and field is E naught by 16. Now this is a pretty straightforward question. We are interested in calculating the torque about origin. This is important to understand. Torque about origin. Many a times they may ask about a different point. So this one is simple. We just want to find it about origin. So this is the position vector and this is the force acting, and we can apply the direct formula. The direct formula is R cross F. So this question is all about calculating the cross product. I, J, K. First you will write R. Be careful. First you write the R 1, 1, 1, and then you write 2, 1, 2, 2, 1, 2. So we solve it and we'll get I cap minus K cap as the answer. So option 1 is the correct answer for this. Alright, let's move on to the next question. This question is based on photoelectric effect. It is a direct application of the formula incident light Hc by lambda, or it is equal to work function plus the maximum kinetic energy, and maximum kinetic energy is, let's say, Ke max. Okay, we will express everything in electron volts. So first he says the wavelength is lambda. So when we have lambda, at that time this is 2 electron volt and the work function is given to be 1 electron volt. That means this energy is 3 electron volt. Now in the second case, he has made the wavelength lambda by 2. So when I make the wavelength half, then the energy will become 6 electron volt, and this should be equal to phi plus Ke max. Phi is the same. Phi is an intrinsic property of the material. It is not dependent on the energy of the incident radiation. So what I get is Ke max is equal to 5 electron volt. Option 3 is the answer. Okay, now this is a question on error analysis. Looks like a lengthy question. Looking at the data, I think we should solve it very carefully. So let's write it down. So what we are interested is, we are interested in calculating the percentage error in the measurement of density. We are given mass, radius and length. So density, let's write a formula for density first. So density is mass upon volume, and volume can be written as wire. Wire means cylinder, pi r squared L. So delta rho by rho times 100, the percentage error will be delta m by m times 100, plus, be careful to put a plus sign, although it is r raised to power minus 2, m by pi into r raised to power minus 2, L raised to power minus 1. So this might be a source of error. You have to write plus 2 times delta r by r plus delta L by L. And okay, let's multiply with 100 to find the percentage error. So delta m is 0.003 divided by 0.60 multiplied by 100 plus 2 times of delta r is 0.01 divided by 0.50 again into 100 plus 0.05 divided by 10 again multiplied by 100. So this will be 3 by 6 plus this will become 1 by 0.5, that is 2 to the 4, plus this will become 5 by 10, 1 by 2. So 1 by 2 plus 1 by 2 plus 4, it makes it 5. So the percentage error is 5. Be careful whether it is talking about percentage error or relative error. The percentage error is 5. So answer must be 5 in this case, option 3. So in this question he is talking about a rectangular metal strip moving out of a uniform magnetic field, so into a region of free field. So there is a magnetic field like this, maybe cross, maybe dot, I don't know, and this field exists like this, and we have a rectangular metal strip which is moving out, and we want to think about when the loop is partially inside the magnetic field, we want to talk about the plot. So what sort of plot will be there? We have to talk about time variation. So this is clearly a case of motional EMF. So think of these three conductors. So this portion and this portion. These two horizontal portions will not have any EMF induced, because EMF we can write motional EMF as BVL, and these three vectors must be mutually perpendicular. So for the top and the bottom part, velocity and length are parallel. So only this one is the one which is having all three perpendicular to each other. So the EMF will be BVL. So EMF will be BVL, and clearly it does not vary upon time. So answer is option 1. This is again an assertion reason based question. Let's read it carefully. So we are talking about a Young's double slit experiment. The fringes produced by red light are closer as compared to those produced by blue light. So it is talking about beta fringe width, which is lambda d by d. Now beta is lambda d by d. Let's verify whether this is correct or not. So beta is lambda d by d. Closer means beta is less. For beta to be less, wavelength should be less. Now you must remember this, in VibGeo this is increasing order of wavelength. Red has longer wavelength, this has a shorter wavelength. Violet, ultraviolet, they are dangerous, high energy, short wavelengths. Red has a longer wavelength. So if this is more for red, beta is more for red. So if beta is more for red, so red light, they should not be closer. So assertion is false. Assertion is false. So there is only one option which says assertion is false. Answer must be 3. But for your awareness, let's verify the reason also for your general knowledge. The reason says that fringe width is directly proportional to beta. Fringe width is directly proportional to, not beta, wavelength, which is true. Beta is clearly directly proportional to lambda. So reason is false. I think I got something wrong. Yes, assertion is false and reason is true. Sorry. So beta is proportional to lambda, which is correct. So the reason is true, assertion is false. Answer is option 3. That is the answer. So we have a ball of mass 100 gram. It is projected with the velocity of 20 meter per second at 60 degree with the horizontal. We want to find the decrease in kinetic energy. So from the point of rejection to the highest point, we are interested in calculating the decrease in kinetic energy. There are two ways to solve this problem. One of the ways could be we just write the velocity at the point of rejection, write the velocity at highest point, we can find the kinetic energy and subtract. Or another thing that comes to my mind is the decrease in kinetic energy must be equal to increase in potential energy. Increase in potential energy would be mgh. So that could be another way. So let me try the second method first. Increase in potential energy. Increase in potential energy must be mgh. H is the maximum height and I know it is u squared sine squared theta by 2g. So increase in potential energy will be mg into u squared sine squared theta by 2g. So the answer is half mu square sine squared theta. That is one of the ways. Or you can do it like this. You throw it with u, and we know that at the highest point velocity is only horizontal, which is u cos theta. So you can just subtract the two kinetic energies. Again we reach to the same answer. The decrease in value is half mu square sine square theta. So we can solve for this by plugging in the values. Be careful, mass is given in 100 grams. So it is half into 100 grams. Let me divide it by 1000, and then u square is 400 into sine squared 60 degree, 3 by 4. This must be the answer, and this value comes out to be 15 joule. So option 2 is the answer. All right, let's go to the next one. Now this seems like a lengthy problem. So after a long time, JEE Main has given questions with quite lengthy calculations also. So we need to solve this carefully. So we are given a body of mass 100 gram, and it is moving in a circular path of radius 2 meter in a vertical plane. We are given the velocity at the bottom. This velocity is 10 meter per second. We want to find the ratio of kinetic energy at B and C. Okay. So let's draw a diagram here. So from here you have thrown with the velocity of 10 meter per second. There is a point here, and this angle is 30 degree. This is B. Then at 90 degree to this, there is a point C. So this angle must be 60 degree. Now the kinetic energy at B must be equal to half m velocity at A squared minus mg hc. What is, sorry, hb, where hb is this height, and this must be equal to r radius. This must be r cos 30. So r minus r cos 30 degree. And kinetic energy at C will be half m vc squared, which is half mva squared minus mg times hc, and hc would be this height, and this hc would be r plus r cos 60 degree. The kinetic energy at B to kinetic energy at C can be calculated by dividing these two expressions. So this is a lengthy equation. It requires for you to calculate. The answer after solving comes out to be option 1, 3 plus root 3 by 2. So this is one of those questions which is going to take time in the exam. So if you are able to save time from other questions, you can solve this. Like this question, this is a question in which you can actually save time. It talks about an LCR circuit. It is saying that at resonance the current is I naught, and if we double the resistance, what happens to the current? Now very simple point to remember is, at resonance the current is, in general current is E by Z, I naught will be E naught by Z. At resonance At resonance, Z is nothing but simply the resistance. So if R is doubled, Z will be doubled and amplitude will be halved. So answer is option 2. So this is a mix of easy question and also some tough questions. You have to save time on easy questions and then you can solve the tough questions also. Okay, question number 41. This is a question which actually wasted a lot of time for many students. There is no correct answer to this question. I will just explain what is the problem in this question. So you see this is an AND gate and this is also an AND gate. So from here we are getting input as A and this we are getting as B bar because of that NOT gate. Now the same B bar is reaching here also and same A is reaching here also. So that means we are getting A dot B bar and also A dot B bar. So this G is getting only one input, that is A dot B bar. So A dot B bar is the only input it is getting and we want an output like this, which is not possible. A dot B bar can either be 0 or it can either be 1. So only two possible outputs are there which is not satisfied by this. Let's verify. If A is 0, B is 0, then A dot B bar is 0. So corresponding to this we will have 0. If A is 0, B is 1, again we have 0. So for first and second case A dot BR is 0. And if A dot B bar is 0, then we cannot have two different outputs for same input. So not possible. So the given situation is not possible actually. So there is no correct answer. This question should be a bonus question. It should be deleted or all students will be given marks for it. Alright, the next question. So we have a symmetric thin convex lens and it is cut into 4 equal parts by two planes AB and CD. This is quite a popular question. We have a lens like this and this has some power P. If I cut it into two halves like this, two identical halves, so the power will be halved, P by 2 and P by 2. But when I cut this further into like this, so one of the parts, you see there is no difference between the upper and the lower part and power depends on the radius of curvature of the two sides. It does not depend on this size. So the power remains P by 2. So answer is P by 2. So if original is 4D, answer must be 2D. So the answer for this question is option 3. Next one, we have a force. It is applied on a particle. It undergoes a displacement. What is the value of B? M. Bm is B meter, I guess is saying. If work done is 0. So for work done to be 0, the dot product has to be 0. So let's take the dot product. Dot product is easy. We just multiply I components, J component and K components. So 2 times 1 from first and second, B times minus 2, then 1 times minus 1 should be equal to 0. So we get 2 minus 1, 1 minus 2b equal to 0. That gives you b is equal to 1 by 2. So answer is b equal to 1 by 2. First answer. Fine. Next question. Oh, this is another easy question. We just have to apply the equation of continuity. There is a tube of length L, radius is 2 centimeter here and the radius is 1 centimeter here. So this area, if this area is A, this area is 4A. The velocity is 2 meter per second. What is the velocity at 2? So we just use A1 V1 is equal to A2 V2. So A1 is 4A, velocity over there is 2 meter per second, A2 is A, velocity we need to find out. So the velocity is 8 meter per second. Answer is option 4. So that is going great. Now I think we'll have some tough questions also, some lengthy questions I'm expecting. A transparent film of refractive index 2 is closed on a glass of refractive index 1.5. What is the minimum thickness of the transparent film for the maximum transmission? Now keyword is maximum transmission, and you need to carefully note down the values of the refractive index. This question requires analysis. So this is glass, and on this glass there is a film whose thickness we are interested in calculating, and this glass has a refractive index of 1.45 and this has a refractive index of 2.0. Now we have a light coming. It is talking about maximum transmission. So this is basically a question of interference in thin films. If you have not done it, you must revise it now. So the path difference will be introduced. Let's understand what happens. So this ray comes, this ray, double arrow ray. From there, a part will be reflected back. I am not interested in that. And a part will go further. So this is double arrow ray again. From here again, some will be reflected back and some will go. Now what happens is, when this reflection takes place, it goes up, comes back, and then it goes like this, and these two interfere. I am showing it on slightly on the side, but it should be actually superimposed on that. So we'll be having two rays. One is the direct ray coming like, one is the direct ray and other is the ray which comes after reflection. So you can see that the ray which comes after reflection suffers reflection and it travels extra distance also. It goes back and then comes like this. So 2t is the extra distance travelled, and since this has been travelled in a medium of refractive index 2.0, so the effective optical path is multiplied by refractive index, so we get 4t. So this ray travels an additional distance of 4t, so that creates a path difference. Further, we need to note one more thing, that if there is a reflection, there could be a phase reversal of 180 degree. We have to check for that whether it is happening or not. So whenever light is traveling from rare to denser and gets reflected, then there is a phase reversal. Now look at this reflection which happens over here. Over there it is going from medium of refractive index 2.0 to a medium of refractive index 1.5. So it is actually going from denser to rare. So nothing happens at this reflection. Now look at this reflection. At this reflection it is going from 2.0 to 1.0 air. So again denser to rare. So no phase reversal. So we are lucky we don't have to do that. So the only path difference is 4t. Now what we are interested is, we want maximum transmission. For maximum transmission, this path difference should be lambda. Minimum thickness. So n lambda lena chahiye. We should take n lambda, but we will take only lambda. So t is lambda by 4. So lambda is 550 nanometer. We will divide it by 4. So 550 divided by 4. So answer is option 1. So this is showing that you are going to get tough questions. You need to practice more. Okay, so this is an integer answer type question. The net current flowing in the given circuit is, this is slightly tricky question. If you are able to identify that, that becomes very easy. Now because of this capacitor in the DC circuit, the branch containing capacitor will have no current. So there cannot be any current in this. If there cannot be any current in this, that means this entire circuit is cut off, because whatever current has to go, it has to come through the capacitor. So you remove all of this. So this is not there. So if this is not there, then what I can see is this 3 ohm and this 6 ohm in parallel. So 3 and 6 ohm in parallel will give us a resistance of 2 ohm. That 2 ohm and this 2 ohm will become in series. That makes it 4 ohm. Now that 4 ohm and this 4 ohm becomes in parallel. That makes it 2 ohm. So the equivalent resistance is 2 ohm. Therefore a current of 1 ampere must come. So answer is 1. Okay, next question. So this again seems like a lengthy question to me. We have a proton. So proton ka charge 1.6 times 10 raised to minus 19 coulomb. Mass is given to us 1.6 into 10 to minus 27 kg. Now it is moving undeflected in the region of crossed electric field. For undeflected we should have V is equal to E by B. The force due to magnetic field and force due to electric field must cancel each other. Now the electric field is switched off. As electric field is switched off, it will move in a circle of radius r. So V is E by B and R is mV by QP. I know R is known to me, V is known to me, mass is known to me, charge I know. Okay, so I want to find out the electric field. Electric field will be V times B. From here I can find the value of B as mV by QR. So electric field is V times B. B is mV by Q times R. So it is mV squared by QR. Now you plug in the values. V is known to you, R is known to you, and E is known. E we can find out. Let's find out. 1.6 times 10 to minus 27 divided by charge is 1.6 10 to minus 19 into V squared. V is 2 times. So 4 into 10 is to power 10 divided by radius. Radius is 2 centimeter. 2 into 10 to minus 2. So I can find out E. 1.6 will cancel out. This is 2. I can guess answer must be 2. Still I will verify. So this is minus 27 minus 19 minus 8 plus 10 plus 2. So this comes out to be 2 into 10 to 4 Newton per coulomb. So yes, the answer is 2. Alright, so we are almost there. 3 more questions left. So we have two long parallel wires X and Y separated by a distance of 6 centimeter and they carry currents in opposite direction. We want to find the resultant magnetic field at point P. The resultant magnetic field due to a long straight wire is mu naught I by 2 pi A. That is the formula involved. Because of the 5 ampere current, the field should be downward. Because of the 4 ampere current, field should be outward. So I need to subtract. So mu naught times 4 ampere divided by 2 pi times A. A is 4 centimeter minus mu naught times 5 ampere divided by 2 pi times the distance becomes 10 centimeter. So 10 into 10 to minus 2. Though this is what we are required to solve. We can plug in the value of mu naught as 4 pi times 10 to minus 7. So this is 2 into 10 to minus 7. I will take this common. This is 4 by 4 into 10 to minus 2 minus this is 5 by 10 into 10 to minus 2. So this makes it 100 and this makes it 100, this makes it 50. So 50 to the 100, so 100 into 10 to minus 7. So that is 1 into 10 to minus 5. So answer must be 1 for this question. So we have a parallel plate capacitor of area 16 centimeter square and the separation between the plates is 10 centimeter. It is being charged by DC current. Now this is a question on displacement current. So it is talking about displacement current. So two key points you need to understand that the total conventional current in the wires which are charging the capacitor, that is equal to the total displacement current, and this total displacement current is uniformly distributed between the plates. So the total current which is a 6 ampere it must be uniformly distributed between the plates. So 6 ampere is distributed in an area of 16 centimeter square. Now we are interested in calculating the current in an area of 3.2 centimeter square. So I by 6 must be equal to 3.2 by 16. That gives you I is equal to 6 into 3.2 by 16. So this is 10 to, so 1.2 ampere. So the current is 1.2 ampere. Now I am really like happy to see this trap given over here. They are answering in milliampere. Note this thing very carefully. They gave this current as in amperes, but they are asking the answer in milliampere. This is very important to note. So I have to convert this into milliampere. So I have to multiply it by 1000 and the answer becomes 1200. So the final answer is 1200. We have a tube of length 1 meter which is filled completely with an ideal liquid of mass 2m. This is again a common source of error. You might take it as m and get a wrong answer. So we have a tube of length 1 meter. Let's say L. It is completely filled with a liquid of mass 2m and it is closed at both ends. It must be closed, otherwise it will flow out. Now the tube is rotated horizontal plane, in a horizontal plane about an axis. So it is spinning like this. So gravity has no role to play. Force exerted by the liquid at the other end. So when I spin it like this, then the liquid will try to push out and it will try to press at this force, at this end. So if I draw the free body diagram of the liquid, I will see a pressing force on the liquid, which is what we want to find out. So let's talk about in ground frame. In ground frame, what I see is this entire liquid moving in circle, and I am interested in calculating this force. So I can just take the center of mass, which will be at a distance L by 2, and the acceleration of the center of mass will be omega squared times r. R is L by 2, and I can simply write total external force is equal to mass into acceleration of center of mass. So I can write F is equal to mass. Mass is 2m and the acceleration is omega squared L by 2. So that makes it F is equal to m omega squared L. So omega squared will be F by ml. So I get omega is square root of F by ml. L is given to be 1. So I put 1 here. So I get root F by m. Therefore, you can clearly see that this alpha is going to be 1. So the answer to this question is 1. So that brings us to the end of this session. I hope you learned some new things in this, maybe some problem solving methods or some formula. I wish you best of luck for your next exam, which is the JEE Main Stage 2 going to be in April. May you do your best. Thank you.